Welcome to this session where we are going to discuss about the Module-2, Session-4. I am Professor Santosh here. Fine. So in the previous session, as we have discussed, so we had been introduced, or I introduced you another form or another method of mathematical induction. That is what we had, the recursive definition. And while making you familiar with the recursive definition, what it was going to be, I took in a very good example of a snowflakes or quotes snowflakes, and I just shown you exactly how we are going to think or how we are going to implement a concept of recursion on the real world example, or something which we can implement or derive the concept of recursion into something which we need to reproduce the same structure again and again in the same procedure. Fine. And even while deriving that or while discussing about the snowflakes problem or the example, the equation which I derived, I told you those are the general forms, the general form of equation, and which we had put into, or which we can express later in two ways. One, the explicit method or the explicit way. The second is the recursive method or recursive way. And so both were going in hand. Fine. So that is when I know what is explicit form, then I can think about a recursive form, or when I know what is a recursive form, I can think about an explicit form. And even in the other case, if explicit form is given, we have seen exactly how we are going to derive this to look or this to have its own recursive form. And the recursive form, what we had derived it to be an explicit form. So for this, we have just taken a simple example of even number. Fine. So using even number, we have discussed about this. And even I just told you within a common communication that the set of elements what I am going to put, I will start from A of 1, not A of 0. Hence, the very first element in the set, whatever you are going to put in sequence, it is going to be from A1, A2 until AN. Fine. So with respect to this, even I just asked you to solve on these problems. Fine. These three problems which I had asked you to give a try. So this is two sets of problems. The first set was the explicit form has been given and you were supposed to derive its equivalent recursive form or recursive definition. And the second problem, so the recursive form has been given, you need to derive it to have an explicit form. So now if we have given a try, that's good. Fine. And with the hope you have understood that, but let me make sure you understand in a better way. Fine. Hence I will just try to solve those three problems. Along with that, I will just take a few more examples and I will make sure I will reach this concept to you in more better way. Fine. Hence for that reason, we'll just take the very first problem what I had been given to you. So the very first problem what I had given is, that is, I'm going to have AN, so which is explicitly defined as 5n. Now what does this mean? So what I say this, that means now whatever the set of elements I am going to have, that is now whatever the elements, that is E, I am going to have, now whatever the element I am going to put into this, it is sure by the explicit form that it is going to be multiple of 5. Fine. So now if I am going to say n is 1, I am going to have 5. If I am going to say n is 2, I will be having 10, 15, so on. Fine. Now this is what explicit form is going to help me in having set of elements into my list or into my group of elements. Fine. So now let me derive or follow a procedure where I am going to represent this explicit form in a recursive form. Right. So to do that, the very first step is just find what is A1. So make sure A is going to be 1 and find what is A1. So A1 equals the value of n is 1, hence this is going to stand at 5 into 1, hence 5. Hence I am not going to give more detail in this, because instead of writing 5 into 1 equals 5, I will just directly write it as 5. You can easily understand why I written 5 over here, hence I am not going in detail. So now, in a similar way, So find what is A2. So A2 is going to be, so as you have been guessed, or it should be 10. And the A3 is going to be 15, and so on, so on. So I can derive it until n. Exactly I don't know what is n, but few elements I am going to derive. Fine. So you can derive 5 elements, you can derive 3 elements, but the reason why I am stopping at 3 is, so these 3 elements will give me enough evidence how exactly the recursive form should be derived. Hence for that I have been stopped at 3 elements. But if you want, you can go until any number of elements of your choice and the way you like. Fine. So now keeping this in mind, I need to find what is the difference between these elements. That is, the set of elements, now what I am going to put is 5, 10, 15 and so on. I am going to have 5, 10, 15 and so on. So now I need to find the difference between the first, the second element, second, the third element and so on. If I am able to fetch this pattern, in what pattern the elements have been derived, then I can easily form this into a recursive way. Fine. And so for that, I am going to find what is the difference. Difference in the sense, it is subtraction. And to find what is the difference, what exactly I am going to do here is, so I'll just subtract 10, which is A2 minus A1. So which is going to stand at, so 10 minus 5. Right? It's going to be 10 minus 5. Now what is 10 minus 5? It is going to be 5. Hence the difference between the first element and second element is 5. This is what I have been derived. So now just to make sure, we'll even check for the second difference also, because on this one difference I cannot relay what the sequence is going to flow. At this point, at a outlook, if I just look at this, I can be sure, I can make sure that this is going to be with the difference of 5. But I need to show evidence. Hence for that, I am going to say A3, the third element, minus A2, which is going to give me A3 is 15, 15 minus 10 is 5. Now this is an evidence for me, or enough evidence to say the difference is going to be 5 always between any number of elements what you are going to derive. So now what it's going to be, in general what it's going to be, that is, now I am going to take the same statement again, or you can take up even the second statement, but as a base statement, let me take the first difference what I have been computed with. Fine. And so for that I am going to have A2 minus A1 equals 5, because the difference is 5. So now to find A2, I need to have, so 5, I will be shifting this at the other side, which becomes plus A1. And instead of writing it as 5 plus A1, which is also equivalent to A1 plus 5. In any other way you can write. Hence I need not explain much about this for you. Hence I will write this as A1 plus 5, because this looks better for me while expressing or while explaining. Hence only for that reason I have written A1 plus 5. If you want, even you can replace this as 5 plus A1. So both are same, no much difference. And now I am going to have A2 equals A1 plus 5. Now just think, can I express even this statement in the same form? Yes? Yeah. I am going to have A3. A3 is equivalent to 5 plus A2, or A3 equals A2 plus 5. Now just observe, I am going to have A2 and A1 over here. I am going to have A3. If I derive this, A2 is going to be here. Hence, if this is n, this is going to be n minus 1. This is n and this is going to be n minus 1. And so now in general, the way I am going to write this is an equals an minus 1 plus 5. Now this is the recursive rule, what I have been put. But remember what I told in the previous session. Whenever you want to have a recursive rule, you need to always think about 3 components. The very first component is the base value or the basis condition. or the base condition. Now in this, if I just look, the very first element which had been derived, that is the A1, becomes the base value, base condition, or the basis of a recursion. Hence, the A1 value, that is 5. Now, this becomes my basis condition or the base condition or the very first value. Right? And the second part of recursion, what I told you was the recursive rule. Now, whatever the general rule have been derived into in a general form, now this is going to be my recursive rule. Now, apart from this, the next thing what I told you was from where the recursion starts. Fine. So now already I know what is A1, hence I need not find what is A1. I need not use this form for A1. If I am trying to use, what is going wrong here? What is going to happen here is, I am going to say A1 equals A1 minus 1, which is A0. Can you find what is A0? You cannot. Hence, for that reason, I need to make sure and evidently show that when you apply this recursive rule, you need to make sure the value of n is going to be greater than or equivalent to 2. Hence, so for n is greater than or equivalent to 2. Hence, so now for the given explicit form, the recursive way is going to be A1 equals 5, and the recursive rule is an equals an minus 1 plus 5 for n greater than or equivalent to 2. Now this is how I am going to derive, or how I am going to represent an explicit into a recursive. Now this is going to be my explicit form, which I have been converted this to be an recursive form. This is what the recursive form is going to look like. I hope I am clear. So now we'll just take the second example too. We'll just take the second example and we'll just try to solve that also. Fine. And the second example is an equals n of n plus 2. That is, I am going to have the explicit form as an equals n of n plus 2. Now similarly, what I have done in the previous example, the same steps I am going to follow. Hence, I am not going to much explain about this problem, but look the way how the problem will be carried on to form the recursive definition of this given explicit form. So now, as you all expected, I am going to find what is A1. So A1 will be 1 into 1 plus 2, which is going to stand at 3. This is going to stand at 3. Or so 1 into 1 plus 2, yeah, it's going to be 3. I need not much explain over how I'm going to get 3. Or let me give a clear picture about this better. I'm going to have 1 and 1 plus 2, so which is going to stand at 3. Good. And now, what about A2? What about A2? So now for A2, I'm going to have 2, so 2 plus 2. So which I'm going to end with? So 2 plus 2 is 4, 4 plus 2 is 8. I'm going to end with 8. And what about A3? So A3 equals, so 3 into 3 plus 2. So 3 plus 2 is 5, 5 into 3 is 15. Fine. Now, so the first few elements what I have got, and now as usual you will expect that I need to find the difference. Now if I find the difference, 8 minus 3 is 5 and 15 minus 8 is 7. The difference is not common now. Difference is not common. And now I cannot depend upon this difference. I cannot depend upon this difference. So just think whether I can represent this sequence A3, 8, 15, some other pattern. Just observe the pattern. So the pattern, what it can be. Now just observe this. Fine. So now I am going to subtract this 8. I am going to subtract this 8 with 3. Just find what I am going to get. That is, I am going to have 8 minus 3, which is going to give me 5. Now this difference, just think, can I express this in a different form or not? So this 5, can I rewrite this 5 as multiple of 3? So if that's the case, I'm just going to say this as 2 plus 1 into 3. So I'm just thinking about something multiple of 3. Fine? Or I can just think about multiple of 2. Let me think about multiple of 2. Hence, I'm just going to have 2 into 1. I'm going to have plus. So 2 into 1 plus 3. I can even think about multiple of 2. So later on, we'll see how exactly this has been derived. So next, think about this 8 and 15 now. So 15 minus 8 is going to give me 7. So now again, just look, can I write the 7 with the multiple of 2 plus 3 or not? Can I do this? Yes. So this is possible because I am going to have 2 into 2, which will end with 4, plus 3 will give me 7. And so this is going to work fine for me. If you want, you can derive one more element and just try to check out. Just try to check out whether it is going to end with the value or the pattern of what I have been given here or not. Fine. So now keeping this in mind, so now how can I derive this? Now this is A1, this is A2 minus A1, which is 5. Now can be expressed in the form of 2 into 1 plus 3. Is that fine? So now, so just to make sure, I'm going to find what is A2. So A2 equals A1 plus 2 into 1 plus 3. So this is what I'm going to end with now. So now in general, you can make this as AN equals AN minus 1 plus 2 into 1 plus 3. And now whatever the general form I have been written, this is going to be my recursive rule as I have explained. And now the A1 value, this A1 equal 3 will be my base value or the basis condition of the recursive, and from where it should start. So now I know what is A1 already, hence I need to start from n is greater than or equivalent to 2. Now this is what the recursive form of a given explicit form is going to be. Hence, so now by this problem, just try to understand every time the difference is not going to work. Fine? You need to think about some pattern. Always think about in what better pattern I can represent this given sequence. If you are able to do this pattern, now your job becomes easier over here. Fine. So now we'll just see the next problem where we are going to have the recursive definition, which I need to convert it in explicit form. That's the reverse of what I'm going to do here. A1 is going to be 4 because it's a recursive definition, hence I'm giving what is the basis condition is. Now what the recursive rule is going to be? So AN equals A n minus 1 plus n. This is a recursive rule. And from where the recursion is going to start? Again, it's going to be for n is greater than or equivalent to 2. Fine. So now when a given form is in a recursive form, now you need to convert this into an explicit form. The very first step is, again, don't try to derive what is A1, A2, A3, so on. It's a reverse way. If it is from explicit to recursive, you start from A1 and you end at AN. If it's the other way, if from recursive you need to derive the explicit form, start from AN, reach until A1. This is what you need to do. So remember always this. Whenever it's going to be an explicit form, you're going to move from A1 to AN. If it's a recursive to explicit, you're going to move from AN to A1. That is what you need to keep in your mind. So now, having AN equals AN minus 1 plus n, the next element what I'm going to have, it is going to be, I need to replace this AN, whatever the value I got here, whatever the value I am going to have here, so now this should be replaced with this an. Now this an should be replaced. This an should be replaced with n minus 1. I need to replace this with n. N should be replaced with n minus 1 and keep all the factor as it is. And so now I am going to end this as a. N is replaced with n minus 1 and minus 1 is taken as it is, and now n is replaced with n minus 1. N is replaced with n minus 1 plus n. Now how did I end with this? Fine. So for that, now this minus 1 was taken as it is and this n was taken as it is. Only I substituted for n as n minus 1 and n as n minus 1 in the form, in the equation, because when I say what is an minus 1, what is an? An is n minus 1 and n minus 1. So in the place of n, replace n minus 1. In the form of this n, I am going to replace n minus 1. So this is how I am going to end with. So in general, I can just say this as a, or let me write over here, a n minus 2 plus n minus 1 plus n. Fine. So now if I just go for the next stage, this n should be again replaced with n minus 1. Again replace this with n minus 1 and replace this with n minus 1. Fine. And if I going to replace this n minus 1 again, I am going to end with, so n minus 1 minus 2 will give me n minus 3 plus n minus 2, because n minus 1 becomes n minus 2 for me, and this n minus 1 and n will remain as it is. Fine. So this is how I am going to derive. So now you can just check out for what is n minus 4. N minus 4 is n minus 3 plus n minus 1 and plus 1. So if I keep on going, I started with an, from an n minus 2, from n minus 2 I have reached n minus 3, from n minus 3 I have reached n minus 4, so on. I am reducing step by step the value of n until where I am going to reduce, until a1. I am going to reduce until a1. That is, I am going to have a1. So now what a1 is going to be? What is a1 is going to be? So a1, when is going to be n minus 4, I am going to have n minus 3. Now if I want to make this as 1, now what I need to end with? I need to end with n minus 1. That is, if I want to have a1 over here, I am going to write this as a n minus 1. Is it fine? So now plus, if it is n minus 1, here I am going to have the next value, which is going to be 2. The next value is 2, and I am going to have 3, and so on until n minus 3, n minus 1 and n. Hence for that, let me do as n minus 1 plus n, because when it is going to be a1, it is going to be 2. Hence for that case, I have written this as 2 over here. Hence now this is going to be equivalent to a1 plus 2 plus 3 plus so on until n. Fine. Now just observe here. Just observe this form. Now this form is going to be in the form of sum of n natural numbers. Now can this be sum of n natural numbers? Yes. Now this can be sum of n natural numbers, but with one condition. That is, there should be value 1 again here. There should be a value 1, because the sum of n natural numbers will start from 1. Hence now you cannot say a1 is 1 here. Hence I need to include 1 in this pattern. Hence so let me work out those things here. So now equals a1. I need to add 1 for this pattern. I am going to add 1 for this pattern and I am going to subtract 1. So it will remain at the same. So a1 minus 1 plus 1 plus 2 so on plus n. Fine. I am going to have a1 minus 1 and I am adding plus 1 here. So minus 1 plus 1 get cancelled and still the equation will stay at the same end. Fine. Hence I am going to have this as the pattern. Now this becomes starting from 1 until n. Now this becomes my sum of n natural numbers. And you know what is the form of sum of n natural numbers. I am going to have a1 minus 1 minus 1. So now this should be replaced as 1 by 2 n into n minus 1. Right, now this is the sum of n natural numbers form. So now what is a1? Now what is a1? Just look at the base condition. a1 is 4. Hence I need to replace this as 4 minus 1 plus 1 by 2 n of n minus 1. So if I just subtract this, now this will be 3 plus 1 by 2 n of n minus 1. Fine. And this is what I am going to end with. I am going to end with an explicit form. That is for the given recursive form. Fine. And I have been finded what is the explicit form is going, that is an equals 3 plus 1 by 2 n into n minus 1. Now this is the explicit form of a given recursive definition. Fine. So if you have any doubt with this, you can discuss. Clear? So now this is how we are going to convert an recursive form into explicit form and explicit form into a recursive form. And as I told, please do remember this. If I am going to convert an explicit form into a recursive form, you are going to start at a1 and end at an. And if you are trying to convert a recursive definition into an explicit form, start at a1, reach until a1. That is what I am doing. I started with an, I have reached a1. Whereas in the previous example, we tried to find what is a1, a2, a3, and at the end, we try to reach what is an. This is what the formulas you are going to work out with. So this is the three problems what I wanted to discuss with you. So now we'll see few more examples how exactly this recursive definition should be dealt while converting. Fine. Now just take this particular recursive form, which we are going to try to prove what is the explicit form is going to be. That is, I am giving the form as, so C1 equals 5, comma, C2 equals 3, where Cn equals 3Cn minus 1 minus 2Cn minus 2. Fine. So now for whatever I have been given, and this should be because I already know what is 1 and 2, hence the value of n should be greater or equivalent to 3. Fine. So now this form has been given here. So now I need to show that this is equivalent to Cn equals minus 2 to the power of n plus 7. That is, I need to prove this. That is, the recursive definition has been given, as well as the explicit form is also has been given. I need to show. So hence, show that the given recursive form is equivalent to this given explicit form. Now, how to show this or how to prove this? Now, to prove this, so we can think about a mathematical induction again here. So now, how we are going to hold this at this point? Now, to prove that with the mathematical induction, we know that what is C1 and C2. The very first step is I need to verify. The first step is verify. If you have forgotten, let me just have a recap of that. In mathematical induction, first I need to verify. Second, I need to assume the given equation is true for the kth element, and I need to prove it for k plus 1 element. Fine. Hence, C1 and C2 has been given, hence the very first element now becomes the value of n at 3. Hence you need to now check out for C3. Now what does C3 is going to be? Will this equation hold good for C3 or not? Hence to have C3, now what it is going to be? So I am going to have Cn as C3. So C3 equals, so 3 into C of n minus 1. Now what is C of n minus 1? So n is, I am going to have 3. So 3 minus 1 minus 2 into C, 3 minus 2. And I am going to end this with, so C3, C2 minus 2, C, C1. Now what is C2? C2 is 3. Hence I am going to have 3 into 3 minus, I am going to have 2 into 5. And this I am going to end with, so 3 into 3 is 9. 9 minus 2 5s are 10, which I am going to end with minus 1. So now just think, now this solution should be made sure, can I represent this minus 1 in form of minus 2 to the power of n plus 7 or not? Can I put in this form or not? So to make sure I am going to put in this form, I am going to rewrite this minus 1. Can I express this minus 1 in form of minus 2n plus 7? So for sure I am going to have plus 7. So now to make this by adding plus 7, if I want to make this as minus 1, what should be added? I am just going to give here. So that is minus 1 equal x plus 7. Now what x should be? So x equals minus 7 minus 1. X is going to be minus 8. Hence, I am going to have minus 8 over here. Now, this is equivalent to minus 1. Is it fine? So, now, can I express 8 in the form of 2 to the power of something? Yes? So, if I say 2 to the power of 1, it's 2. To the power of 2 is 4. 2 to the power of 3 is, yes, it's going to be 8 for me. Hence, now, I am going to replace 8 as 2 to the power of 3 plus 7. So now C3 equals minus to the power of 3 plus 7. Hence it is true. It is true for the first case. Hence it's verified. Now for the K, we are going to assume that Ck equals 2 to the power of K plus 7 is true. We are going to assume this. But now I need to prove it for K plus 1. Hence, so this is proved. Hence, we'll just go for the third step where I am going to have Ck plus 1. Hence, I am going to have Ck plus 1. Ck plus 1 equals 3C K plus 1 minus 1 minus 2 C K plus 1 minus 2. This is what I am bringing over here. Now this is equivalent to, so 3C, so I am going to have K plus 1 minus 1 as Ck minus 2, so K plus 1 minus 2 is Ck minus 1. I am going to have K minus 1. Now what is Ck? What is Ck? I know that Ck is minus 2 to the power of K plus 7. Hence I am going to replace this as 3 into minus 2 to the power of K plus 7 minus 2 into what is K minus 1? I am just going to replace this with K minus 1 as into 2 multiplied with minus 2 to the power of K minus 1 plus 7. Is it fine? So now just to simplify this, I am going to have 3 into, that is minus 3 into 2 to the power of K plus 3 7s are 21 minus or minus into minus, it becomes plus. So plus, so 2 into 2 to the power of k minus 1 minus 14. That is 2 sevens are 14. So now to go further, I am just going to have minus 3 into 2 to the power of k here, and this is 2 into 2 to the power of k minus 1 can also be written as, hence we will write minus 2 to the power of k plus, so 21 minus 14 will give me plus 7, hence I will just write plus 7 here, and 2 into 2 to the power of k minus 1 is 2 to the power of k. It's going to be 2 to the power of k. So now just observe here, 2 to the power of k here, 2 to the power of k here, and so now I am going to take a common of this. This minus 3 plus 1 into 2 to the power of k plus 7. Now this is equivalent to, so minus 3 plus 1 becomes minus 2. So now this minus 2 and into 2, that is, so minus 2 into 2 to the power of k plus 7. I am going to have minus 2 into 2 to the power of k plus 7. Now minus 2 or 2 into 2 to the power of k can be written as, I am just going to write as plus 7. Fine. So 2 into 2 to the power of k plus 1 can be written as 2 to the power of k plus 1, and negation or minus remains as it is, so plus 27. Now what is this? This is c k plus 1, hence this is proved because it is minus 2 power of n and k plus 1 plus 7, hence proved. So due to this proof, I can say this recursive definition is equivalent to this explicit form. So this is how we are going to think and how we are going to implement. So we'll just try to solve one more problem. Fine. So the next problem what we are going to consider is, I'm just going to say c of 1 equals 1, so which is also saying c1 equals 1, and so c of n is equivalent to, so 2 into c of, so to the floor of n divided by 2. And now just observe this floor value divided by 2. So for n is greater than or equivalent to 2. So now you need to find for, and you need to find what is c of 67. Fine. Now this is a recursive definition again. A recursive form has been given and you need to find what is c of 67, the value of c of 67. Now just observe here, so c of 1, it is equivalent to c1 equals 1. I can write this as c1 equals 1 and this is cn equals 2 into x, but in the form of function we have represented using a brackets over here. Fine. And for this case I need to find what is 67, but now the operator what I am going to use, this is called as floor. Fine, this is called as floor. So this is how this operator is going to work. I'm just going to give an example over here. Now the floor of 2.5 is going to be the integer value 2. I am just going to ignore the decimal value. Even if it is floor of 2.9, I am going to take this as 2 only, because every time I am going to use this integer value, not the nearest value. Fine, I am not rounding off to the nearest value, hence I am going to use this as floor. It's a floor operator. Fine. And in case if I am going to give the ceiling as 2.9, this will be 3, and the ceiling of 2.2 will be again 3, because I am trying to round off to the upper value. I am trying to round off to the lower value. So this is how the seal is going to work, or the floor is going to work. Whatever the problem has been given with is going to be with the floor. Fine. And so now with this I am going to try to find what is C67 is going to be. And so C of 67 equals, replace n with 67, and so 2 into, so C of floor, n value is 67, 67 divided by 2 floor. So now what I'm going to end with this value? So I'm going to end with, so 67 divided by 2 is, so it is 33.5. I'm going to end with 33.5, hence, so 2 into C of 33.5. Now what is 33.5? According to our rules, it's going to be 33. Hence, I'm just going to erase this. So this is going to end with 33. So now at the end of first value, I'll be ending at 33. Now I should not stop at this. No, this is not the value of 67. I need one value for this. Hence, again, so C of 33, I'm ignoring 0.5 here because, so okay, I'll just go and rewrite this. Fine. So this should be the floor of 33.5. This is better now. Fine. Hence, I'm ignoring decimal and I'm taking only 33. So 33 equals, so 2 into, so C of 33 divided by 2. Now I'm going to end with, so 33 divided by 2 is, so 32 is 16, so 16.5. So 2 into C of 16.5. Now I need to ignore 0.5 and I'm going to take 16. So C of 16 equals 2 into, so C of 16 divided by 2. So which I am going to end with 8, and so 2 into C of 8. So I need not ignore anything here, and so I am going to have C of 8 equals, so 2 into, so C of 8 divided by 2, and I am going to end with 2 into, so C of 4. I'm going to end with C of 4, and again, yeah, I think I'm missing something over here. Fine. Now where I'm going to have 2, so now if you just observe, every time I need to multiply with 2. I've been just left out with this because, so 2 is always multiplied, hence I'm going to have 2 here, that is, so 2 into 2, hence, so at this end I'll be having 2 to the power of 2. At the first case, I'll be having 2 to the power of 2, and at this, I'll be having 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, and so on. So on, I'll be just keep on executing this, and I'm going to stop at C of 1. I'm going to stop at C of 1. Until 1, I'll be keep on dividing. So when I stop at C of 1, or when I say C of 2 equals, I'm going to end with C of 1. I'm going to end with C of 1, so which is going to be 2 to the power of 6, because I'll be multiplying 2 6 times. Fine. Now this is what I'm going to, and now I know what is C of 1. C of 1 is 1, hence I'm going to have C of 26. Hence at the end, so C of 67 is equivalent to 2 to the power of 6. Right? So this is what I am going to do with, so given value, when I want to find the value, this is what I am going to do with. Hence, so don't forget, as I did over here, so don't forget to multiply 2, because in each steps I need to keep on multiplying 2. Hence, I'll be having 2 into 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, and 2 to the power of 6 at the end when I'm going to have C of 2. So this is how we are going to solve the equation when we are going to have such evolution is going to be involved. Fine. And please try out with this simple problem if you can. And in the next session, we'll discuss another interesting topic. So thank you for this session.